Hey guys, today we're going to use some algebra to solve some word problems. So we're going to take what we did last week, solving equations, and apply it to some real world problems. Start on this videos first. It's some pretty basic problems, and then I'll make another video doing some geometry type problems. All right, there's three steps I like to follow when solving word problems. Step one, I define the variable, and I always call that let statement. Let x equal something in the problem. Let y equal something in the problem. You can choose any letter you'd like. A lot of times I like to choose a letter that makes sense in the problem. If I have somebody in the problem named Mary, I might use M for Mary. If I have dimes and nickels, I might use D. I might use N. So you can use any variable you would like in your problem. Next step is set up equations and solve. Translate into an equation using your let statements, then solve. We're going to do some of the translating when we're setting up our let statements. We'll do some of our translating when we're setting up our equations and solving. So you'll see what I mean when I get to the examples. And last, you're going to define your answer. Give exactly what the problem is asking for. A lot of y'all would solve a word problem and be like, all right, x equals 10. Woohoo, box it, I'm done. Well, was that really what the problem was asking for? You got to ask yourself, what exactly was I supposed to be solving for? That's great. I needed X to solve for what I really needed, what the real answer was. The number of brown M&Ms in the candy bag. Well, X might have been the red ones, and the brown ones could have been 2 times the number of red ones. All right, so let's see. We're going to apply this to some problems, and it'll make more sense. So, example one. And I'm going to I'm so this is something I've always done it. I'm in the habit of doing it. I will do it forever and ever. Is I'm going to underline and identify stuff as I read. So the larger of two numbers is 4 more than the smaller number. If the sum of the number if the sum of the numbers is 74, find the numbers. All right. I meant to underline is. Okay, so we're looking for the numbers. I'm looking for two numbers. What kind of numbers are they? One is large, one is small. So two numbers. So let's set up our let statement. Oh, I forgot I did this. Those are our math words that I identified. So one, define your variables. Use your let statements to define your variables. Well, I'm going to let x be the smaller number. X is my smaller number, so let's think about what they said about the larger number. The larger of the two numbers is 4 more than the smaller number. So we're going to let the larger number be x plus 4. 4 more than. Remember, more than is one of those, switch, go back, reverse words. I like to think of it. If you notice, I did not write 4 plus the plus 4. You're adding 4 to something. And it doesn't matter so much in addition, it matters in subtraction. If this said 4 less than and you wrote 4 less than, you would be wrong because 4 less than means you're taking 4 away from. Very important. When you see more than, less than, think, wait a second, it goes in front of the number. And if you're consistent with adding and subtracting, you'll make less mistakes in the long run. All right, so more than means plus and equals is. Next step. Let's set up our equation and solve. We've already done a good bit of equation setting up over here. Look. What math operations or words are still left over in the problem we haven't used yet? I have not used this sum and the is. So sum is the addition, the answer to an addition problem. So what am I adding together? A large number And a small number, my large number plus my small number is. So my large number plus my small number is. All right? Sum is plus, is means equal. My large number plus my small number is. X was my small number. X plus 4 was my large number, is 74. So now let's do some math. First step, combine like terms. To x plus x. Next step, subtract 4 from each side. Then there you go. 2x equals 70. Next step, divide by 2. X equals 35. All right, let's not just stop right there. X does not just equal 35. Well, X does equal 35, but we got to ask ourselves, is that it? Am I done? Am I going to write X equals 35 and box my answer? No, sirree. What am I looking for? The numbers. So give exactly what the problem is asking for. The problem was looking for two numbers. Well, X is 35. Did I answer one of them? Yeah, the smaller number was X. So that's one of your answers right there. And then your other one was X plus 4. 35 plus 4 equals 39. Your smaller number is 35. Your larger number is 39. Those are your answers. It's always best practice to go and check your work. Is 35 plus 39 equal to 74? It is. That's your answer. Great job. All right, our next example. Garrett has $1 less than 3 times as much money as Liz has. Together they have $179. How much money does Garrett have? So this time, keep in mind, our answer is going to be Garrett. How much? Keywords. I saw an awful lot of math words. Garrett has $1 less than 3 times as much money as Liz has. Together, that is actually a math word. They have $179. Let's define our variables. All right, what do you think? Garrett has $1 less than $1 less than 3 times as much money as Liz. So we could make Garrett X, or we can make Liz X. But Garrett has, I didn't make that, that's an equals there. Garrett equals. So why don't we define Liz? Let's make Liz X. Oh, Liz with an S. And then Garrett is 3 times 1 less than. Remember, you took the one, when you do less than, it's being subtracted from 1 less than 3 times Liz. All right? What's our next step? Set up equation and solve. All right, what math operations are left that we have not used? We haven't done that together. So together means you're going to add them. You're adding them together, right? What are we adding together? Liz and Garrett. Liz and Garrett together. Liz and Garrett together is $179. There's Liz. There's Garrett. Together they have $179. Now let's just math it out. Combine like terms. Add 1 to both sides. Divide by 4. Bam, X is 45. Now this is a case, if you stopped here, there's not even really anything for me to, like, no, it's wrong. The question asked, how much money does Garrett have? So give exactly what the problem is asking for. Go back to these. You're always going to go back to your let statements. Your let statements are going to come back over here. Plug in what you know. I know X is 45. That's Liz. Liz has $45. Garrett, 3x. X is 45 minus 1. Garrett had 1 less than 3 times Liz right here. Garrett has 1 less than 3 times Liz. There you go. Bam. Garrett has $134. That is the answer to your question. All right, one more example. Let's clear this off. Bye. Example 3. There are 10, let's start underlining. Let's not use yellow. There are 10 less. There are 10 less red Skittles than orange Skittles in a bag. The orange Skittles are also twice the number of red Skittles. Find the number of red and orange Skittles. So I want both in the bag. All right, let's define our variables. So we're going to make, let's see, I made X orange. X is orange. I could, though this is a case where, why didn't I call it O? I could have called it O. That would have made sense. Well, I guess you can choose any letters you'd like. And then your red. There are 10 less red Skittles. There you are again, that take away from. When you say less, come over here. You're going to subtract 10 from something. You're subtracting 10 from the red. There are 10 less red Skittles. You are subtracting the 10 from the number of orange Skittles because there is 10 less red. All right. Now let's translate into equation using our let statements. All right, so now this one is not a sum. I did not see the word sum. The orange Skittles are. R means equals, just like is meant equals, R means equal. The orange Skittles are also twice the number of red Skittles. What is that going to look like? R is our math word there. Oh, and twice. What does twice mean? You're going to multiply by 2. Here is your orange Skittles are twice in X minus 10. That was your red Skittles. So I don't know if it would help you maybe. Your orange Skittles are twice your red. If that little intermittent step helps you, do it. Now O, I called that X. Red, X minus 10. Okay, do that step if that helps you. Even do this, taking the words, and do that before you put it in the algebra, before you put the little expressions in. All right, let's go and solve. All right, we have parentheses here. Guess what that means? Distribute, our favorite D word. 2x minus 20. Subtract 2x. So I have negative x equals negative 20. Now, normally I move the smaller x, but I didn't do that this time because that would just leave nothing over here. So I went ahead and bit the bullet and I have a negative x. So what's in front of that x? A negative 1. To get rid of that negative, you divide by negative 1. X is 20. Now let's see, give exactly what the problem is asking for. The problem wanted to know how many red and orange Skittles. X is 20. X was our orange Skittles. There are 20 orange Skittles. I don't know why that popped in there before. That's orange. X minus 10, that's red. All right. This is exactly what the problem had asked me. There are 20 orange Skittles and 10 red Skittles. So I guess what I want you to take away from this video is if you break word problems down, underline all your math words. You did this in middle school. You're doing it again now. You're going to do it next year in geometry. And define your variables, set up your equation, go back and read and give exactly what the question was asking for, and you should be good to go. Have a great day. Bye.